Good morning guys, welcome back to the next part of software design process. Into the previous part what we covered what is software design, what are the why there is need to go for the software design, what are the different principles behind the software design like efficiency and what we can say simplicity are the two major factors. Then we have talked about the ways we can do the software design, basic named as an software principles in the four parts. That part is well discussed in structure design methodology. Then we have discussed about the module level concept. What is module, types of modules, coupling, cohesion, different levels of cohesion, and one important part, the relationship between coupling and cohesion. Greater the cohesion, coupling will be lower. That's the important part. Now we are focusing on the next part called as what? Object oriented analysis and designing. As the name suggests, or why there is need to go for object oriented, if you see the recent trends in IT industries, most of the companies prefer to go with an object oriented approach. The programming things what we are adding, and to work with the programming language, object oriented programming language, the design standards will be followed automatically of object oriented analysis and design standards. So what actually it says, it can be represented it in a single line, that the real world problems, because the object is real world entity which can be a conceptual, which can be a tangible, that but can be represented with some rules regulations. So anything in the real world, maybe actual, maybe imaginary, we can call it as an object, and once we got the object we can deal anything with that object. So this is real world problem scenario what we are going to see in object oriented approach. As the name suggests, object oriented analysis, object oriented designing. So what is difference? So analysis deals with problem design domain, whereas the object oriented design deals with the solution domain. So analysis focusing on what the problem is, and object oriented design is focusing on how to give the solution for it. So it can be represented in single diagram, it can be represented in the simple single diagram. This is the real world problem, and analysis tries to focus on the problem domain representation, while the designing is focusing on the solution domain representation. So simple, understand whatever the real world problems. So end of the day, software is nothing but what? Automation to your manual process. So you must be aware about the manual process. That is real world problem. That manual process can be done by the help of a software into an automation process. So to bring that things into automation process, we need to understand the real world scenarios. So this is what the object oriented analysis and design. So as the objective of both analysis and design, OA and OOD, is to model some domain. These are the two different things, even though it looks like similar. So it is often not clear where analysis ends and design begins. Different people have different view on it, but the major difference in object oriented analysis, that is OOA and OOD, is due to different domains of modeling in types of object that come out of analysis and designing. The object during OA focuses on problem domain, as I rightly mentioned, whereas OOD focuses on the solution domain. So OA focus on problem domain, that these objects are called as semantic objects, whereas OOD solution domain consists of semantic object as well as other objects. So solution domain objects include information, application and utility objects, and this information and interchange object deals with user interface, which is not directly part of problem domain but represents some aspects of solution. So that interface is one of the highlighting point to understand the difference between object oriented analysis and object oriented designing. So analysis is investigation, while designing is implementation, what problem you understood. This is what we discussed, analysis, designing. Now, while we are working with this object oriented analysis and designing approach, we are going to work with the following concepts. First is information hiding. In technical language we call abstraction. Coupling, relation between the different modules. Cohesion, that coupling talks about dependency. Cohesion, it specifies how tightly the bound elements of modules are. Reuse, object oriented technology is so famous because of its one of the major highlighting characteristics, that is reusability or resilient structure. Means someone has already done, just by making a small changes, customizations, I can reuse it for my next purpose. So reusability is one of the major constraint while we are talking about this software designing. Now, the different design notations and specifications that we are going to follow. Here we will follow a simple object oriented approach in terms of UML language. So we will understand UML concepts and then we'll come back to this design methodology and all these parts. So what is UML? UML stands for Unified Modeling Language. So there are the different diagrams, like starting, if you see, some diagrams are represented as a static diagram, some parts are represented as a dynamic diagram. So basically if you see, total 9 diagrams are there. And if I say, the names are like use case diagram, class diagram, object diagram, component diagram, deployment diagram, activity diagram, state chart diagram, collaboration diagram, and sequence diagram. So to draw this, these are the simple diagrams, and to represent these diagrams we are going to understand the flow. So some diagrams represent the flow, some diagram represents the structure. So those who represent the structure known as static diagram, and those who are going to represent the flow between the different objects, that is named as dynamic diagrams. So I hope the difference is clear, and different notations we are going to use here. So let's talk about the first part. So the first part we are talking as design methodology, means the things how we are going to use it, by understanding the flow and by understanding the different parts. So frequently design approaches are some graphical notations to represent the design. Notations are compact pictorial representations. That is, for example, if I say the class, how to represent class? Class, what is class? Class is nothing but group of similar objects. So what is object? Object is anything in the real world, we will call it as what? Object. So object is represented as a simple rectangle telling the object name. Next is objects, similar objects together, which forms a class. How to represent the class? Class is represented with a simple rectangle having 3 compartments. The first compartment tells us about the class name, second talks about its attributes, and third part talks about its method, operation, behavior, how your class is going to get behavior. So rectangle having 3 parts, first as a class name, second as attributes, third as an operations, methods, behavior, how your object is going to get represent. And then if I collected all objects, all class, I need to define the relationship between that objects and class. That can be that relation can be represented in various terminologies like association, multiplicity, dependency, generalization, specialization, that is a part of a relationship, that is composition, aggregation. These are the various different types of relationship that what we have covered into the class. So again, this can be represented with simple line starting from source to and destination. Indications is a different parts, so you can refer my previous class notes to understand this. Then the methodology here, how we are going to complete that 9 diagrams. So whether we first focus on the structure part and then we will focus on dynamic parts, that we have to be precise with this conceptual to how we are going to proceed from analysis part to designing part, we will call as a design methodology. So this slide talking about dynamic modeling. Next I'll talk about the static modeling. Now dynamic modeling means, try to understand, as I said, dynamic means continuously who are going to get change. Means what is going to get changed? Your input. How your input is there, based on input the flow is going to get changed. We will call it as a dynamic model, and here we are going to draw the various diagrams. So they have given one simple scenario about the restaurant system, and this is the simplest diagram, and this diagram is known as sequence diagram. Objects, the first part, menu is an object. That dot 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 line is lifeline of an object, and that complete square on there, this that's we are calling as a focus of control. So this is a simple event trace diagram named as, yes, sequence diagram. This is now functional modeling for counting the real world problems that we have discussed. It can be represented in dynamic model like this. This is the class diagram. Class, rectangle with 3 compartments. For example, file is the class name, attributes, and how your file class is going to get word with just what we can say operations, methods. Our get word is AOF, end of the file, like this. And that diamond and straight line, the diamond is representing is a part of relationship, and there are two types of a relation is a part of relationship, maybe strongest relationship or lower type of relationship. And here it is represented as a, the diamond is not filled, means lowest type of relationship, weaker type of relationships rather we can say, and it is, yes. Hands on, we have drawn 9 diagrams. If you are remembering, we have drawn 9 diagrams, and I have used one open source tool to show you, demonstrate part. Starting from use case 2, we have completed the class diagram, and then we have covered the forward engineering concept also. So what is forward engineering? If you are remembering, what is forward engineering? After completion of a class diagram, we have generated the code in Java, if you are remembering. So that is forward engineering. Code is get generated by diagrams, and if you already have a code, from the code we can draw the diagram, that is reverse engineering. So it supports reverse engineering also. So any doubts so far? These are the probable questions. Thank you.